Hi everyone, my name is Corrine Toracchio and I'd like to talk to you about Reactthreefiber and counting sheep. Before I begin, I'd like us all to take a look at one of my favorite photographs. It is the spectrum of visible light as seen through a spectroscope. When the pandemic first began and the world was deciding how to spend their time indoors, I chose to acquire a new skill, 3D modeling with Blender. This video, posted by the Blender Guru on YouTube, was quite popular and it walked me through how to model a donut. On April 21st, I was excited to post the first renderings of my donut. And then I was even more impressed with myself when on the following night, my donut had sprinkles and a cooked texture. The night after that, I had created a glass cup and saucer with water and coffee. And a few nights after that, I had made a sheep and a fence. A little over 2 years ago, I became a mother to this beautiful little girl named Sophia. But Sophia's sleep began to regress as our schedules were disrupted from staying at home. As I looked at my sheep and fence, I couldn't help but be reminded of the times when I was a child and I would count sheep with my parents as a way to go to sleep. And so, with the help of a library called Reactthreefiber, I created the following scene for Sophia to help her get some rest. This scene will loop indefinitely, but I would like to take this time to introduce you to Reactthreefiber and three.js. Reactthreefiber is a React renderer for three.js on the web and React Native. Three.js is a JavaScript library that brings 3D animated graphics to the web using WebGL. And WebGL is a JavaScript API that accesses computer graphic hardware in order to render the output into a web page's canvas element. So why use Reactthreefiber? Building dynamic scene graphs declaratively with reusable components makes dealing with three.js easier and brings order and sanity to your codebase. In other words, you can tap into React's infinite ecosystem in order to make working with three.js simpler. First and foremost, we must understand what makes up a scene. At a minimum, a scene is composed of a light source, a mesh, and a camera. And the renderer will render the contents of that scene from the point of view of the camera. In three.js, a scene is created as follows. You define a scene, a camera, and a renderer. You need to set a clear color on the renderer and also specify its size before you append the renderer to the DOM. If we compare this to in Reactthreefiber, we can see that much of the boilerplate code has been abstracted away into this canvas component, where we need to define the position of the camera. The next important concept to understand are meshes. And a mesh is comprised of a geometry, which defines its shape, and a material, which defines its color, textures, and how the light reflects off of it. An example geometry from three.js would be the box geometry, where you can alter the width, the height, and the depth. To add your mesh to your scene in three.js, it's extremely straightforward. First, you define your geometry and then your material in order to compose your mesh, and then you would add those imperatively to the mesh to your scene. In Reactthreefiber, adding the mesh to the scene becomes declarative, and so we can see the beauty of component composition come to life. Here, we define a box component which returns a mesh that's been composed of a geometry and material, and we add that to the box, and we add the box directly to our scene. You'll also notice that the same applies to our light sources. Now that we've added our meshes to our scene, we can finally create our first animation, or our first moving picture like Edward Muybridge in 1878. So, how do we animate in three.js? Well, first we need to create a render loop. And a render loop is a recursive function which leverages the web API's request animation frame function. This is a function that takes a callback and runs at roughly 60 frames per second, for which we pass in our render function. In this render function, we should specify any permutations we'd like to make to our meshes. In this example, I'm rotating the cube on its x and y axes by varying amounts. At the end of this render loop, we must tell our renderer to render the scene, and finally, we must make an initial call to render so that we can kick off this process. In Reactthreefiber, this can be achieved neatly within the component itself. First off, we need to create a reference to our box so that we can apply the transformations to it. And then the render loop is packaged neatly into this useFrame hook so that we need not worry about it and so that we can focus on our animation directly. Here we can rotate our cube on its x and y axes by different amounts, and ta-da! We have our first moving picture in Reactthreefiber. Now, this was an introduction to Reactthreefiber and three.js, but I would like to state that counting sheep did not happen overnight. In fact, in total, it took just over two and a half months to complete, and the learning curve for me looked something like this. I had struggles and encountered bugs that caused me quite some pain. One of my early versions of counting sheep looked something like this. While I don't have time at present to share more about my particular experience, you can view the extended version of this presentation on my website, or I encourage you to reach out to me in Discord, and I will be happy to tell you more about it or answer any questions that you have. Thank you, and sleep tight.